Download this code from codegib.com, link in the description below. Troubleshooting bad file descriptor, error 9, in make builds on GitHub Actions. Encountering the bad file descriptor error, specifically error code 9, during your make build process on GitHub Actions can be frustrating. This error generally indicates that your make process is attempting to read from or write to a file descriptor that is no longer valid or has been closed. This can stem from various underlying issues, including race conditions, improper file handling, or interactions with specific tools. This tutorial will guide you through understanding the error, identifying potential causes, and providing practical solutions with code examples. We'll cover common scenarios, debugging techniques, and best practices to prevent this issue from recurring. Understanding the error. What is a file descriptor? In Unix-like systems, including Linux, which powers most GitHub Actions runners, a file descriptor is an abstract indicator used to access a file or other input/output resource, such as a socket or pipe. When you open a file, example using fopen in C or open in shell scripting, the operating system assigns a unique integer value, the file descriptor, to represent that open file. Subsequent operations, reading, writing, closing, reference this file descriptor. Bad file descriptor error. This error signifies that the file descriptor being used in a system call, read, write, close, etc., is invalid. This could be due to the file descriptor never being opened in the first place. The file descriptor was previously closed. The file descriptor represents a resource that no longer exists. The file descriptor is out of range, example negative. A race condition where one process closes the file descriptor while another process attempts to use it. Why is it common in CI/CD, GitHub Actions? CI/CD environments like GitHub Actions execute builds in parallel and often involve complex interactions between different tools and processes. This increases the likelihood of race conditions or unexpected file descriptor management issues. Common causes and solutions. Let's delve into the most frequent culprits behind the bad file descriptor error in make builds on GitHub Actions and outline corresponding solutions. 1. Concurrent file access/race conditions problem when multiple make targets or shell commands attempt to access, read or write, the same file concurrently without proper synchronization, they can interfere with each other's file descriptor usage. This can lead to one process closing a file descriptor while another is still trying to use it. Solution use flock or similar locking mechanisms. Introduce file locking to serialize access to shared files. Flock is a simple and effective utility for file locking in shell scripts. Explanation flock nfd command. Flock attempts to acquire an exclusive lock on the file associated with file descriptor fd. If the lock is already held by another process, nflag makes it non-blocking and immediately returns with a non-zero exit code, which we ignore in this case for simplicity, but in a robust application, you'd handle the failure appropriately. We use a specific file descriptor, 200, for the lock, which isn't typically used for other purposes. This ensures both targets use the same lock. The bash C executes the command within a new shell, ensuring that the flock command is contained within the shell's scope. This is important because flock releases the lock when the file descriptor associated with the lock is closed, usually when the shell exits. Make target ordering /dependencies structure your make file to ensure that targets that modify the same file are executed sequentially. Use make dependency system effectively. Explanation * target 2 is defined as depending on target 1. This forces make to execute target 1 fully before starting target 2. This eliminates the race condition. Atomic operations use atomic operations, if available, to minimize the window of opportunity for race conditions. For example, use mv to atomically rename a temporary file to its final destination. Explanation * instead of directly writing to output.txt, we first write to a temporary file output.tmp, and then use mv to atomically replace the contents of output.txt with the contents of output.tmp. mv ensures the rename operation happens as a single atomic step, minimizing the risk of data corruption or race conditions. 2. Pipe closures and subprocesses ****. Problem * when your makefile involves complex command pipelines or creates subprocesses, example using $, or backticks, file descriptors associated with these pipes and subprocesses might be prematurely closed. Solution * ensure pipes are fully consumed * if a command pipeline writes to a pipe, make sure the receiving end fully consumes the data before the writing end is terminated. Use wait command * if you launch background processes, using and, explicitly wait for them to complete before continuing. This prevents the parent process from exiting and closing file descriptors that the background processes might still be using. Redirect output redirect the output of subprocesses to files to avoid issues with pipe closures. This can be particularly useful if the output is large or if the subprocess might take a long time to complete. Carefully manage standard error * be mindful of how you handle standard error, str. If you redirect str to the same file as stout, example 2 and 1, ensure that the reading end of the pipe is still active when the process tries to write to str. 3. Incorrect file descriptor usage in custom tools / scripts ***. Problem * if you're using custom tools or scripts within your makefile, they might have bugs related to file descriptor management, example closing the wrong file descriptor, not closing file descriptors after use. Solution * review and debug your code * carefully examine the code of your custom tools or scripts. Look for potential file descriptor leaks, where you open a file but don't close it, or incorrect closing of file descriptors. Use debugging tools use debugging tools like lsoff, list open files, or strace, system call tracer, to monitor file descriptor usage. lsoff ppid lists all open files and file descriptors for the process with process ID PID. You can find the PID of the make process or the subprocesses it launches. *trace trace equals file ppid traces system calls related to file operations, open, close, read, write, for the process with process ID PID. Example, debugging with strace and lsoff. 1. Identify the process * first, identify the process causing the error. This might require examining the logs or adding print statements to your makefile. 2. Use strace * run strace on the identified process. This will output a stream of system calls related to file operations. Look for close calls followed by read or write calls to the same file descriptor that cause the bad file descriptor error. This will indicate where the premature closure is occurring. 3. Use lsoff * while the process is running, or immediately after it crashes, use lsoff to see all the open files and file descriptors. Examine the output to see if the file descriptor in question is still listed as open or if it was closed unexpectedly. 4. Environment limits, file descriptors. Problem the operating system imposes limits on the number of file descriptors a process can have open simultaneously. If your build process exceeds this limit, you might encounter bad file descriptor errors. This is less common on modern systems with high file descriptor limits, but it's still a possibility. Solution check limits use the limit n command to check the current file descriptor limit. Increase limits, carefully if necessary, you can increase the file descriptor limit. However, be very cautious when doing this, as it can impact system stability. On GitHub Actions, you'll generally not need to adjust these limits. Close unnecessary file descriptors. Ensure that your scripts and tools close file descriptors when they are no longer needed. 5. GitHub Actions specific issues. Problem certain interactions with the GitHub Actions environment itself might lead to file descriptor issues. For example, issues with caching or artifact uploading. Solution update actions versions. Ensure you are using the latest versions of your GitHub Actions, as older versions might contain bugs related to file descriptor handling. Review action logs. Carefully examine the logs for the GitHub Actions that are involved in the build process. Look for any error messages or warnings that might indicate a problem with file descriptor management. Simplify your workflow. If possible, simplify your workflow to reduce the complexity of the build process. This can sometimes help to avoid issues with file descriptor handling. Consider disk space. In rare cases, insufficient disk space can indirectly cause file descriptor issues. Make sure your runner has enough free disk space. GitHub Actions usually provides ample disk space, but it's worth checking. Example GitHub Actions workflow for troubleshooting. Here's a workflow demonstrating how you might use trace and lsoff in a GitHub Actions workflow to debug a bad file descriptor error. Explanation 1. Check out code. Checks out your code repository. 2. Install trace and lsoff. Installs the necessary debugging tools. 3. Run make with trace. Executes the make command. Replace problematic _target with the actual target that causes the error. It uses trace to trace file-related system calls and saves the output to trace.log. 4. Get PID of make process. Finds the process ID of the make process using grep make. This is important because trace and lsoff need to know the PID of the process you want to monitor. 5. Run lsoff on make process. Runs lsoff on the make process, saving the output to lsoff.log. 6. Upload artifacts. Uploads the trace.log and lsoff.log files as artifacts, which you can download from the GitHub Actions run to analyze locally. Debugging workflow steps. 1. Trigger the workflow. Commit and push changes to your repository to trigger the GitHub Actions workflow. 2. Analyze the artifacts. Download trace.log. Open the trace.log file in a text editor. Look for close system calls followed by read or write calls on the same file descriptor that result in the bad file descriptor error. Download lsoff.log. Open the lsoff.log file in a text editor. Examine the list of open files and file descriptors for the make process. Verify that the file descriptor causing the error is actually open. Important considerations. Minimal reproducible example, MRE. When seeking help from the community, always provide a minimal reproducible example. This makes it much easier for others to understand the issue and provide assistance. A good MRE should be self-contained. Be as small as possible. Demonstrate the problem clearly. Isolate the issue. Try to isolate the specific part of your makefile or build process that is causing the error. This will help you to focus your debugging efforts. Comment out sections of your makefile until you've narrowed it down. Log thoroughly. Add extensive logging to your makefile and scripts. This will help you to understand the sequence of events that lead to the error. Version control. Make sure your code is under version control, example Git. This will allow you to easily revert to previous versions if necessary. By following these steps and understanding the potential causes of the bad file descriptor error, you'll be well equipped to troubleshoot and resolve this issue in your make builds on GitHub Actions. Remember to leverage debugging tools, carefully review your code, and simplify your workflow where possible. Good luck.